Alright, so hello everyone, I'm Sebastian, and I'm just going to give a rough overview of what the Arduino board is and some of its capabilities, specifically in the context of the APSC150 lab for 2014. So, as you guys know, you get a little kit like this when you're building for case 1, and in it you'll have an Arduino. But I just want to make it clear that Arduino exists in many different forms in this. There's the larger one, which is the Mega, and then they go all the way down to this size. So there's a little bit of a difference, but they're all the same board, they all use the same code, they're all practiced the same way. So essentially what an Arduino is, it's a microcontroller. So it's a small computer, same as your laptop, same as your desktop if you still have that type of thing, and they're just shrunk down to a really small size. So actually the computer is this little part here, or if you look at the smaller chips, it's this tiny little square. So that's what's doing all the processing, controlling all the outputs, all the inputs. Now the way the Arduino works is you program it, as I hope you've realized, through the USB, and you're essentially declaring a few sets of conditions. So first you're declaring what the variables are. So for example, you can declare that there is a door. After that, you can declare conditions. So a condition could be if someone knocks at the door. And then finally, within the conditions, you declare an action. So you can say you open the door. So you have the variable, there is a door. You have what to do if something happens to that variable. So the door is knocked on. And then the action that follows, which is opening the door. And that's essentially the way coding works with an Arduino. It's the way most computers actually function. It's just listing a variable, what could happen to that variable, what to do. So it's obviously very important to have a form of output for an Arduino. That's really the whole reason we're using them. So I just have a simple sketch here to demonstrate the simplest form of output you can really have from them, which is blinking. So here we have the LED blinking once every second. Pretty easy to do, only a couple lines of code. Not particularly useful. Slightly more useful is when you combine it with an input. So in this case, we're going to take a button, and when we press the button, it's going to turn on an LED. So we plug it in this, off, on, off, press the button, on. A little bit more useful, you can actually start to do stuff with that, especially if we replace the LED. Now, obviously in the context of the APSC150 lab, we're using a little joystick to control a servo. Now before I explain exactly how that setup works, I'll explain a little bit behind resistors. So I'm assuming you all remember high school physics, which explained a little bit about resistance, voltage, amps, those types of things. These are resistors. So are these, so are these. There's hundreds of different types. Now they're all fixed value. So all a resistor does is it takes an input voltage and it basically resists the voltage so that it comes down. So say an input voltage of 5 could go down to an output voltage of 4 volts, which means 1 volt of work's being done. Now that's useful in its own right in certain circuits. You'll be given some examples which have to use a resistor if you want it to not basically fry the board. But they're also really useful when you start having variable resistors. So that's what this thing is. The joystick is a variable resistor. So it's changing the amount of resistance, so the amount of electricity that can go through the system. And why that becomes important is that Arduino has these neat little ports over here, the analog ones. So there's from A0 to A5, so there's 6 ports. And what analog allows is for you to read on a scale from 0 volts to 5 volts. So it's broken up into hundreds of different increments, and depending on how much electricity is being put in, how much power, it will read a certain scale and complete a certain action. So you can actually put into the system how much you want it to change at. For these ones, it's normally about halfway through that it starts to trigger. Now, for the servo, we have And one annoying fact for it. It's operated the same way as the LED is. It's on, it's off. You can control how many rotations it does. That's what's really useful with the servo. The dark brown is the negative, so the ground. The red is the voltage, so 5 volts. And the orange is your data, so that needs to go to a digital pin, just like the LEDs. And then what a lot of people are getting confused about today is what is a breadboard. So a breadboard can come in many different shapes and sizes. These are also breadboards, but they all work the same way. So if you look really closely at this one, you can actually see it's transparent. There's just a metal clip of 5 prongs, all connected to the same base. So when you put in one wire here, the entire row, or column, depending how you look at it, is powered the same way. So that means if I put 5 volts here, the entire row is going to be powered by 5 volts, which is basically the same thing as connecting the wires together, except it saves you a lot of time and twisting the wires. Pretty user-friendly, which means when you start having a circuit like this, which is our joystick circuit, we can do it pretty quickly, switch it around if something's not working. So just to demonstrate what the joystick allows you to do, and explain in a little bit more detail, we take the analog, we'll take the digital, and then we'll plug in the power and the ground. And that allows us to essentially control the servo, which is being all operated by the joystick. So, my roommate, everyone. So, the joystick is pretty useful. It's just varying the voltage as you move it along, which is telling the Arduino to change the output to the servo, and that's making the servo spin. Now, a couple of tips when you're using the wires, especially on something that starts to get complicated like this: color code them. By convention, always put power, so the 5-volt red, ground is always black. That will save you a lot of hassle because they're often shared by most of the electronics. Digital, I tend to make orange, and analog I tend to make yellow, but really each individual pin should have its own color if it's a specific control wire. Also, in the sense of just general common knowledge for electronics, you're normally trying to complete a loop. So you're running from the positive back to the ground. So if your loop isn't completing somehow, if it's not making a full circuit, then there's an error in the way you wired it. That's probably why it isn't working. So hopefully this helps, and if you have any questions, please let me know.